Scientists have issued a new, long-range forecast for planet Earth, and it points to an inevitable, silent apocalypse. A joint study from researchers at NASA and Japan's Toho University has calculated the final expiration date for our atmosphere, predicting a future where the very air we breathe will vanish from the sky, spelling the end for almost all life as we know it. This startling conclusion is not the product of a wild guess, but of immense computational power. Using supercomputers, the team ran more than 400,000 simulations to model the long-term evolution of Earth's biogeochemical cycles. The result was a clear, if distant, timeline for our world's demise. The culprit is not an asteroid or a man-made catastrophe, but the one constant in our sky, the sun. In approximately 1 billion years, our aging star will trigger a chain reaction that will strip the atmosphere of its life-giving oxygen.
The mechanism for this apocalypse is a story of tragic irony. As the sun ages, it gets hotter. Deep in its core, it relentlessly fuses hydrogen into helium. As the helium ash builds up, the core contracts and heats up, causing the sun's outer layers to burn even more brightly and radiate more energy. This slow and steady increase in solar radiation will have a profound impact here on Earth. The extra heat will dramatically accelerate the natural weathering of silicate rocks like granite and basalt. This process, in turn, pulls vast quantities of carbon dioxide out of the atmosphere, locking it away into the planet's crust. For millennia, this process has been part of a stabilizing climate feedback loop. But with the sun's output relentlessly increasing, this system will be pushed past its breaking point. The planet will begin to actively scrub its own atmosphere of the carbon dioxide that is the fundamental food source for almost all plant life. This marks the beginning of the end. Photosynthesis, the miraculous process by which plants and algae consume CO2, water, and sunlight to create their own food and release oxygen as a waste product, will begin to fail on a planetary scale.
As CO2 levels plummet over millions of years, the world's great oxygen factories, its lush rainforests, its sprawling grasslands, the vast blooms of phytoplankton in the oceans, will begin to starve. A slow-motion famine will grip the entire biosphere. Plant life will wither and die, and with it, the primary source of atmospheric oxygen will be shut down. According to the research, which was published in the prestigious journal Nature Geoscience, the final stage of this collapse will be terrifyingly swift on a geological timescale. Once CO2 levels drop below a critical threshold, the complete de-oxygenation of the atmosphere could happen in as little as 10,000 years. The oxygen content of the air is predicted to crash to levels 1 million times lower than today. Our familiar blue sky will be gone, replaced by a hazy, methane-rich orange sky, eerily similar to that of the primordial Earth, billions of years ago. To understand this future, we must look at our own planet's distant past. For the first half of its existence, Earth was an anaerobic world, devoid of free oxygen. Its inhabitants were purely microbial, and the air was thick with gases like methane, nitrogen, and carbon dioxide. Then, about 2.4 billion years ago, everything changed. The Great Oxidation event, triggered by newly evolved cyanobacteria practicing photosynthesis, began pumping enormous quantities of toxic oxygen into the atmosphere. This was the planet's first and greatest pollution event, causing a mass extinction of the anaerobic life that had dominated the globe. But from that crisis, a new world was born. The oxygenated atmosphere allowed for the evolution of the ozone layer, a protective shield against the sun's harshest ultraviolet rays. It also enabled the rise of complex, multicellular organisms like us, whose high-energy lifestyles are completely dependent on breathing oxygen. The future that this research predicts is a perfect symmetrical reversal, a great de-oxidation event.
The planet will revert to its ancient state. The ozone layer will disintegrate, and the Earth's surface will be bombarded by a relentless, sterilizing torrent of UV radiation. Life for complex creatures will become impossible. The entire animal kingdom, the product of more than 500 million years of evolution, will be wiped out. Humans, mammals, birds, fish, and insects will vanish. The vibrant, noisy living world we know will fall silent.
But life itself will not be entirely eradicated. The planet will be returned to its original masters, the microbes. Extrophiles and anaerobic organisms, for whom oxygen is a poison, will thrive once more. They will inherit a world scoured clean of their complex competitors, flourishing in the oxygen-poor oceans and the methane-rich atmosphere. Earth will still be a living planet, but its life will be invisible to the naked eye, a microbial shadow of its former glory. While this event is 1 billion years away and poses no threat to humanity, its implications are profound, especially for our search for life on other planets. For decades, astrobiologists have considered the presence of oxygen in an exoplanet's atmosphere to be the gold standard biosignature, a smoking gun for the existence of life. This study forces a radical rethink of that strategy. It suggests that an oxygen-rich atmosphere is not a permanent feature of a habitable planet, but a temporary phase. The full habitable lifetime of Earth is estimated to be over 7 billion years, but this oxygenated window for complex life may only last for 20 to 30% of that time.
This means that when we point our powerful new telescopes, like the James Webb Space Telescope, at rocky worlds in the habitable zones of other stars, we might be looking at planets that are perfectly alive, but are in their pre- or post-oxygen phases. They could be teeming with microbial life, but we would find no trace of the oxygen we were looking for. This forces us to broaden our search, to look for other biosignatures like methane, and to understand that a living world does not necessarily look like our own. This research provides a humbling and powerful perspective. It reminds us that our complex, beautiful world is not a given. We are living in a fleeting golden age of Earth, a precious window of cosmic time where the conditions are just right for creatures like us.